Honestly, I don't do this, but I gotta do this remix right now. Kasiga akong mata, gapangita sa bahina, diri sa brochure na, gapamaligid panty o bra. Ayaw kong inagbayo, dili na ko niisuot, nangitar akong material para sa akong paglulu. Tuara na kita na, ang akong gipangita, akong magsugod na, ayaw na kong gisorbohan. Basig ikang bisika, na ako brochure sa Avon, ipagawas na ang lotion, tapos isugod ang session sa akong pang-masturbation. Oh my god, I'm about to come, ako kay nagawsan, pagkahuman sa akong session, mura kog nahamat yan. Yeah.
Hello and good day. I am Decadent, the Muscle June Clyde of Group 1. Now, in this video is about two-stroke engines and its working principles. So first, what is two-stroke engine? So, a two-stroke engine is a type of internal combustion engine that completes a power cycle by moving one piston up and down twice within a single power cycle, which is accomplished by turning the crankshaft once. In two-stroke engines, there are no suction and exhaust strokes. There are only two remaining strokes, the compression stroke and the power stroke. These are usually called the upward strokes and the downward strokes. Also, instead of valves, there are inlets and exhaust ports in two-stroke engines. Now, what are the working principles of a two-stroke engine? Well, there's mainly two principles: the upward stroke and the downward stroke. Now, for further explanation, I'm going to leave that to the next reporter.
Good day, I am one of the presenter of this group, and our topic is working principle of two-stroke. So, two-stroke engine is a type of internal combustion engine which completes a power cycle with two stroke of the position during only one crankshaft revolution. So, in two-stroke engine, there are no suction and exhaust stroke. There are only two remaining stroke, the compression stroke and power stroke. These are usually called upward and downward stroke. So, my task is to discuss the compression stroke or upward stroke. So, during upward stroke, during upward stroke, the piston moves upward from the BDC or bottom dead center to the top dead center by compressing the charged air petrol mixture in the combustion chamber of the cylinder. Due to the upward movement of the piston, a partial vacuum is created in the crankcase. So, and a new charge is drawn into crankcase through the uncovered inlet port. The exhaust port and transfer port are covered when the piston is at the top of dead center position, and compressed charge is ignited the combustion chamber by a spark given by the spark plug.
Dave Run, so I'm here to explain the two-stroke upward. So, the upward stroke, which is upward movement of the piston, to draw fresh air inside and then to compress the air-fuel mixture. Due to this compressing action, the air-fuel mixture ignites and explosions takes place, which pushes the pistons down. As the pistons goes down, it uncovers the scavenged parts and fresh air comes inside. At the same time, the exhaust valves opens and the waste exhaust gas are removed by the assistance of scavenging. As the pistons move up, the compression stage followed by these two strokes keeps on repeating unless the fuel supply to the cylinder is cut off. So that's all.
So good day, I am Decadent Danyo, and our topic is all about the two-stroke engine principles. So my part is the downward stroke. So when the charge ignites, the hot gases compress the piston, causing it to descend downward and cause the crankshaft to rotate. performing the necessary work. So the piston covers the inlet port during this stroke, compressing the new charge inside the crankcase. The transfer port and exhaust ports are first shown when the piston continues to descend, and as a result, the exhaust begins at the exhaust port. The charge through the transfer port is pushed into the cylinder as soon as it is opened. Most of the exhaust gases are forced out of the cylinder by the charge once it hits the deflector on the piston's crown. The piston is currently positioned at bottom dead center. Despite being partially filled with exhaust fumes, the cylinder is entirely filled with a new charge. Then, with the piston making 2 strokes for every crankshaft turn, the cycle is repeated only.
Hello, once again I'm Decadent Apostle June Clyde. Now, for more thorough justification of the piston's downward motion, the piston moves upward during the compression stroke, which compresses air-fuel mixture, while crankshaft is subjected to a running force due to the downward weight of the expanding gas. The piston moves upward during the exhaust stroke to remove the used gases. So the downward piston stroke causes the crankcase to compress. The increased pressure inside the crankcase forces the valve to close. And that is all for the principle of the two-stroke engine. Now, to wrap this whole topic up, how advantageous is two-stroke engine over four-stroke engine? Well, it is because in a ship, they can be run either clockwise or counterclockwise. Ships don't have gearboxes. If you need to back your ship up, you have to shut the engine down and restart it going to the other direction, which is astern. You can't do that with a four-stroke engine. So two-stroke engines can burn low-quality fuel than four-stroke due to slower speed, and given ships a lot of fuel cost. It's a major operating expense. It is crucial to be able to use the cheapest fuel. Now, that is all to wrap up this topic. This is Group 1, and thank you all for listening.
Access granted.
Good day, sir. I am Decadetorio. So I'll be discussing what is four-stroke engine. So, four-stroke engine kuno kay mo ni siyang tinawag na internal combustion engine. So it utilizes 4 distinct pistons, in which pistons complete 4 separate strokes while turning the crankshaft. So the 4 separate strokes named intake, compression, and combustions, and exhaust. So in this, you will be able to complete 1 operating cycle. So, a complete operation in four-stroke engine, it will be required 2 revolution of the crankshaft. So, required daw 2 revolution to complete one operation in four-stroke engine. So, a four-stroke refers to the full travel of pistons along the cylinder. So, in either direction, most of modern internal combustion powered vehicles are four strokes, powered by either gasoline or diesel fuel. So, four-stroke engines deliver a good balance of power, reliability, and efficiency.
So I'll be talking about the first step in the four-step process of the four-stroke engine, which is the intake stroke. So first of all, we should open the intake valve and close the exhaust valve. And after that, air-fuel mixture will be introduced into the combustion chamber. And in this stroke, the TDC, top dead center, the position wherein it is farther from the crankshaft, will begin to move towards the BDC, or the bottom dead center, which is nearest position is at the crankshaft. And the movement of the piston towards the BDC will create a low pressure area in the cylinder wherein the air will be sealed.
And after that, the inlet valve, or the valve that is responsible for suction and discharging for stroke, will be open for a few degrees in the crankshaft rotation after the BDC. And after that, the intake valve will close, and the air mixture that was introduced in the first step, will be sealed inside the cylinder.
Good day everyone, I am Decadent Bacchus Crystal Meiji, and I'm here to present about compression stroke. So as you can see in the TV, you can see the compression stroke. So here is the BDC to TDC. So I will explain what is compression stroke. In compression stroke, the trapped air fuel mixture is compressed inside the cylinder. So here it is. During the stroke, the piston moves from BDC, this one is the BDC, to TDC, compressing the air-fuel mixture. So this is the air-fuel mixture inside the cylinder. The momentum of the flywheel helps the piston move forward. Compressing the air-fuel mixture allows more energy to be released when the charge is ignited. The charge is the volume of compressed air-fuel mixture trapped inside the combustion chamber ready for ignition. So the air-fuel mixture is trapped inside ready for ignition. The inlet and outlet valves must be closed to ensure that the cylinder is sealed, resulting in compression. So the key point is inlet valve and outlet valve is closed. The crankshaft rotation 180 degrees, or total in 360 degrees.
Power and combustion stroke. The second rotation of the crankshaft begins when it completes a full rotation during the compression stroke. The power stroke occurs when the compressed air fuel mixture is ignited with the help of a spark plug. So, power stroke mahitabo sa higayon nga ang spark plug mo dilaab, the air fuel mixture masunog and an immediate flame is created. So let's proceed to the combustion stroke. Ignition or combustion is rapid, oxidizing chemical reaction in which fuel chemically combines with oxygen in the atmosphere and releases energy in the form of heat. Ang pagkasunog niya kay dali o nag-oxidize chemical reaction kung ang gasolina kay chemically na mag-combine sa oxygen sa atmosfera o kani nagpagawas sa enerhiya tungod sa kainit.
So, good day. So, I'm talking about the exhaust gases, which is the fourth basic components of the four-stroke engine. So, as the piston reaches the BDC, which is the bottom dead center, during the power-up stroke, the combustion is complete and the cylinder is filled with exhaust gases, and the exhaust valve will open during this stroke. In this inertia of the flywheel and other moving parts push the piston to that TDC, which is the top dead center. So the piston will go upward, so and forcing the exhaust gases to the exhaust valve, and the end of the exhaust stroke as the piston is on the TDC, which is the top dead center, and the one cycle has been completed. So it will back to the first cycle, so the intake, the compression, and then the combustion and exhaust rather.
Welcome to Robinson Craft Tech Design. Today, we're going to discuss four-stroke cycle engines. A four-stroke, also four-cycle, engine is an internal combustion (IC) engine in which the piston completes four separate strokes while turning the crankshaft. A stroke refers to the full travel of the piston along the cylinder in either direction. The four separate strokes are termed intake, also known as induction or suction. This stroke of the piston begins at top dead center, TDC, and ends at bottom dead center, BDC. In this stroke, the intake valve must be in the open position while the piston pulls an air-fuel mixture into the cylinder by producing vacuum pressure into the cylinder through its downward motion. Compression. This stroke begins at BDC, or just at the end of the suction stroke, and ends at TDC. In this stroke, the piston compresses the air-fuel mixture in preparation for ignition during the power stroke, below. Combustion. Also known as power or ignition. This is the start of the second revolution of the four-stroke cycle. Exhaust. Also known as outlet. During the exhaust stroke, the piston, once again, returns from BDC to TDC while the exhaust valve is open. This action expels the spent air-fuel mixture through the exhaust valve. Thank you for watching.
Good day everyone, I am Decadet Serrano, and today our group will discuss about the parts and functions of two-stroke engine and the advantages and disadvantages of using two-stroke engine. First and foremost, we'll start by discussing what a two-stroke engine is. So a two-stroke engine is a type of internal combustion engine that completes a power cycle with two strokes of the piston during one power cycle. This power cycle being completed in one revolution of the crankshaft. As the name implies, the two-stroke engine only requires two piston movements up and down in order to generate power. The engine is able to produce power after one cycle because the exhaust and intake of the gas occurs simultaneously.
Parts and function. First, air fuel mixture suction port. The air fuel mixture is drawn into crankcase through the suction port. And the second, transfer port. The compressed air fuel mixture is transferred from the crankcase to the combustion space through the transfer port. And the third, exhaust gas port. Exhaust gas is discharged from the combustion space through the exhaust gas port. And the last is the crankcase. Houses the internal parts of the engine. The air fuel mixture is compressed the crankcase prior to entering the transport. And this is the parts: spark plug, piston, transfer port, Conrad crankshaft, exhaust port, inlet port, or the crankcase. This is the move of the engine. This is the function. Piston travels between top dead center or TDC and bottom dead center or BDC linearly in a straight line. And the second, spark plug, used to ignite the air fuel mixture. Gasoline, petrol engine employ spark plugs and are known as spark ignition engine. Between the diesel engine do not employ spark plugs and are known as compression and the ignition engines. That's all.
Good day, I'm Decadet Louis Caravallo. Today I'm going to discuss the advantages and disadvantages of two-stroke. First, the advantages. First, one, simple design and construction. It doesn't have valves. It's simple as inlet and outlet parts which make it simpler. 2. More powerful. In two-stroke engine, every alternate stroke is power stroke, unlike four-stroke, one in which power gets delivered once every four stroke. This gives a significant power boost. Also, the acceleration will be higher and power delivery will be uniform to same reason. 3. Position doesn't matter. Two-stroke engine can work in any position as lubrication is done through the means of fuel, as the fuel passes by through holes, cylinder, and crankcase. Disadvantage of two-stroke: 1. Less fuel efficiency. For every alternate power stroke, fuel gets consumed every alternate stroke. This makes the engine less fuel efficient, although it results in uniform power delivery. 2. Oil addition could be expensive. Two-stroke engine require a mix of oil in which the air-fuel mixture to lubricate the crankshaft, connecting rod and cylinder walls. This oil may empty your pockets. 3. More pollution. Two-stroke engine produce a lot of pollution. The combustion of oil added in the mixture creates a lot of smoke, which leads to air pollution. 4. Wastage of fuel. Sometimes the fresh charge which is going to undergo combustion gets out along with the exhaust gases. This leads to wastage of fuel, and also power delivery of the engine gets affected. The last, improper combustion. The exhaust gases of get trapped inside the combustion chamber. This makes the fresh charge impure. Therefore, maximum power doesn't get delivered because of improper, incomplete combustion. That's all. Thank you.
Good day everyone, my name is Ibrahim Joshua J. Giliamak, and we, the Group 4, will be discussing about the parts, the advantage, and the disadvantage of a four-stroke engine, since it is very essential how the different strokes differ from each other. Firstly, what is four-stroke engine? A four-stroke engine in a ship is a type of internal combustion engine that operates on a four-stroke cycle. The four strokes of a four-stroke engine are intake, compression, power, and exhaust. The intake stroke brings air and fuel into the combustion chamber. The compression stroke compresses the air-fuel mixture. The power stroke ignites the mixture and produces the power to drive the ship's propulsion system. And the exhaust stroke removes the spent gases from the combustion chamber.
Hi everyone, I'm Decadex John Paul. A four-stroke engine is an internal combustion engine that delivers one power stroke for every 2 cycles of the positions of the pistons. The engine consists of a cylinder head, position, piston rings, crankcase, connecting rod, crankshaft, cooling fins, cam and camshaft, inlet and exhaust valves, intake and exhaust manifolds, spark plug for petrol engines, fuel injector for diesel engines, carburetor for petrol engines, and a flywheel. The engines work through four-stroke, intake stroke, compression stroke, power stroke, and exhaust stroke. During the intake stroke, the pistons move downward to increase the volume, allowing a fuel-air mixture to enter the chamber. During the compression stroke, the fuel-air mixture compressed and ignited by a spark plug. The power stroke generates the engine's power output through the combustion of a fuel-air mixture. The stroke pushes out the remaining exhaust gas. That's all. Thank you.
So, good day. I'm the Cadet Toreta Kajushabi. So, I'm going to discuss the parts of the four-stroke cycle marine diesel engine. So the first part is the rocker arm, then the fuel injector, the cylinder head, the water cooling passage, the camshaft, the com, the exhaust valve, the cylinder, the piston, the gudgeon pin, and the connecting rod. So these parts that I have mentioned will be discussed briefly by the next reporter. That's all, thank you.
I am the Cadet Tindoy. So as you can see, there are three parts of a four-stroke engine. So first is crank pin. It's also known as a rod bearing journal. It's a mechanical device in an engine which connects the crankshaft to the connecting rod for each cylinder. So next is the crankcase, often forms the lower half of the main bearing journals with the bearing caps forming the other half. The last one is a bottom end bearing, a bearing at the larger crankshaft end of the connecting rod in an engine.
Hi, I am Decadent Bingo. So to proceed, the four-stroke cycle marine diesel engine, the engine is made up of a piston. So we all know that it is made of piston which moves up and down in a cylinder, and it is also covered with a cylinder head. And then with that cylinder head, it is being housed also the fuel injector which enters through the cylinder, and through that fuel injector, the inlet and exhaust valves are also housed in a cylinder head and held shut by the springs. So the piston is joined to the connecting rod by a gudgeon pin. So as we all know, that engine is made of piston. So basically, pag nakapasok na yung fuel into that engine, then it starts up. Then as it starts up, so that piston will move up and down. As it moves up and down, so may papasok na air. Then as it closes, then the other piston moves up. Then lalabas yung air. So that will be the exhaust air passing through the exhaust valves. Now, the four-stroke cycle marine diesel engine, there are parts. So we divided this. For me, the rocker arm, the fuel injector, and the cylinder head. So first is the rocker arm. The rocker arm is the port responsible for transmitting the movement of the camshaft towards the intake and exhaust valves of the engine, a process that occurs through a direct contact of these parts with the tappets and according to the movement of the shaft. So as we've seen in the image, so the rocker arm is in the upper head of the engine. Then next will be the fuel injector. It is basically common to most, especially in the motors, fuel injector. Then it is a device for atomizing and injecting fuel into the internal combustion engine. The injector atomizes the fuel and forces it directly into the combustion chamber at a precise point in the combustion cycle. So basically, dito talaga dadaan yung fuel para magsa-start yung engine. Then next is the cylinder head. Sabi ko kanina, cylinder head, there are lots of parts that is being connected with the cylinder head. The cylinder head is a three-piece assembly consisting of a lower member that contains a gas passage, serves as a mounting for injector valves and the ignition plug, and forms part of the combustion chamber. So basically, cylinder head. So there are lots of connections with the cylinder head, the fuel injector, ano pa yun? The inlet and exhaust valves. So that would be all. Thank you.
I'm Deck Cadet Tolang Christian Ray. So next part of a four-stroke cycle marine diesel engine is a water cooling passage. So water-cooled systems is a liquid. Usually water is pumped through pipes. So the liquid takes the heat from the component and dissipates it in radiator. So meaning the coolant that came from the inside of the engine will collect the heat from it and then moves through pipes, comes into the radiator, and then the radiator will release or take away the heat that the coolant carried. So water cooling passage operates on same principle as the engine cooling system in a car where coolant is pumped through the engine and to the radiator. So next part of a four-stroke engine is the camshaft. So camshaft is a mechanical component of an internal combustion engine. The function of this or the camshaft is it opens and closes the inlet and exhaust valve of the engine at the right timing at the exact stroke and in a precise defined sequence. A cam in its simplest definition is a mechanical link that converts rotational motion into linear motion or vice versa. Next part is exhaust valve. So exhaust valve releases burned gases from a cylinder. So the exhaust valve closes during the initial part of the induction stroke. So exhaust valve functions when the combustion inside the cylinder is done and the burned gases needs to be released. So next is a cylinder. A cylinder is a crucial part of engine where fuel is combusted. So in cylinder, the power is generated. So the cylinder consists of a piston and an inlet and exhaust valves at the top. During the stroke, the piston moves from bottom dead center to top dead center, so compressing the air fuel mixture. So the momentum of the flywheel helps the piston move forward and compressing the air fuel mixture and allows more energy to be released when the charge is ignited. In internal combustion engines, the gudgeon pin or the piston pin connects the piston to the connecting rod and provides a bearing from the connecting rod to pivot upon the piston's movement.
In continuation, the connecting rod creates the link between the piston and crankshaft and thus transmits power. It converts the linear up and down movement of the piston into the circular motion of the crankshaft and is therefore subject to tension, compression, bending, and buckling. A crank pin is the part of the crank of a crankshaft to which the connection rod is attached. Crank pins transfer up and down motion between the crankshaft and the connecting rod. The big end of the connecting rod is connected to the crank pin of the crankshaft by way of a bearing. Bottom end bearing is the bearing where bottom of a connecting rod connected with the crank pin of the crankshaft. Bottom end bearing, also known as crank pin bearings. Lastly, crankcase, the metal housing that encloses the crankshaft, connecting rods, etc. in an internal combustion engine, reciprocating pump, and etc.
Hi, I'm Decadet Dacola and I am here to tell about the advantages of the 4-stroke engine. So in 4-stroke engine, always make extra torque than 2-stroke engine at low RPM. Although 2-stroke ones give higher torque at higher RPM, but it has a lot to do with the fuel efficiency. And 4-stroke engine have a greater fuel efficiency than 2-stroke ones because fuel is consumed once every 4-stroke. So less pollution as a power is generated once every 4-stroke, and also as no oil or lubricant is added to the fuel. So 4-stroke engine produces less pollution. And the other advantage of 4-stroke engine is more durability. So we all know that more the engines runs, quicker it wear out. 2-stroke engines are designed for high RPM. If an engine can go for 10,000 RPMs before it wear out, a 4-stroke engine with 100 RPM will run for 100 minutes than other 2-stroke engine which has a higher RPM of 500 and will run for only 20 minutes. So no extra addition of oil, only the moving parts need lubricant intermittently. So no extra oil or lubricant is added to the fuel. And that's all.
Disadvantage of a four-stroke engine: complicated design. A four-stroke engine has complex valve mechanisms operated and controlled by gears and chain. Also, there are many parts to worry about, which makes it harder to troubleshoot. Less powerful, as power gets delivered once every 2 rotations of crankshaft 4 strokes. Hence, 4-stroke is less powerful. Expensive. A 4-stroke engine has much more parts than 2-stroke engine. They often require parts, which leads to a greater expense.
Hi, I'm the Cadet Lawrence at England. So 2-stroke versus 4-stroke engines. 2-stroke and 4-stroke engines are two different types of internal combustion engines. The main difference between the two lies in gear design and the number of power of strokes they produce per cycle. 2-stroke engines are lighter, more compact, and generally simpler in construction compared to 4-stroke engines. They complete a power cycle with just 2 strokes of the piston compared to the 4-stroke and a 4-stroke engine, which result of faster power delivery. However, this also means that they require mixture of fuel and oil to be added to the fuel tank, as they don't have an oil sump to lubricate the engine. Additionally, 2-stroke engines are generally less fuel efficient, produce more pollution, and are typically noisier than 4-stroke engines. 4-stroke engines, on the other hand, are larger and more complex than 2-stroke engines. They have an oil sump that holds the oil used to lubricate the engine, and they are designed to operate on gasolines only. The 4-stroke engine provides a better fuel efficiency, lower emission, and lower noise levels compared to 2-stroke engines. So in conclusion, the choice between 2 strokes or 4-stroke engines will depend on the specific requirements of application, while 2-stroke engines offer more power and more compact. 4-stroke engines offer improved fuel efficiency and lower emission and a quieter operation.